This is the third segment on fourth generation photodynamic therapy. This is one of several different molecules that we have used and still can use if we choose to. We normally use this without the nitrogen-hydrogen moiety that's shown here and here. And sometimes we add a third SO3, that's a sulfate moiety, in place of one of these. That molecule on its own is a very well-known, well-proven photosensitizer. Unfortunately, most people cannot make it pure. They can, but it costs $15,000 to $20,000 for one dose. We've managed to create a new technique for sulfonating this molecule, and because of that, we can produce a perfect blend of disulfonate and trisulfonate. And what that means is that it goes into the blood quite nicely, but it can also pass through the cell wall. On its own, this is the best sensitizer in the world. But we didn't stop there. The big question is, how do you really focus on cancer? Well, they've known for a long time that a nanoparticle was the ideal way to differentiate between cancer and normal tissue. Why? Well, because it's too big to get out of normal blood vessels. But when it gets to cancer, cancer builds leaky blood vessels. Consequently, we put the sensitizer into the blood, it circulates around the body. When it finds cancer, it just pours out into that area. Also, the nanomolecule that we use actually looks like sugar to cancer. And we all know that cancer loves sugar. So the picture that you're looking at here is a scanning electron microscope photo of the actual particles created by our technology. This technology, again, involves basically foodstuff. It's a component that's commonly added to ice cream to give it a more creamy texture, mixed with a component that's added to cure meat like pork and ham. The two put together create this very special molecule, and it surrounds our photosensitizer. It targets the cancer so specifically that very little of it goes into normal tissue. We can see this with an infrared camera. These are bufo-marinas that were used in tests. One of them was given the photosensitizer without the nanomolecule, this guy here. And as you can see, the infrared camera shows up a lot of sensitizer in the normal tissue. With the nanomolecule, far less sensitizers in the normal tissue. That means that they're not as sensitive to the sun, but more importantly, it means that when you put the laser over an area that needs to be treated, it can safely pass through the normal tissue and get to the cancer, which is absolutely full of sensitizer. We've been able to treat down to the center of the brain, down to the center of the lungs with extremely good success. Now, what does the nanoparticle on its own do without the sensitizer? Well, we use it as a drink, a liquid. This is liver cancer. The cells on the left here are perfectly normal, healthy liver cancer cells. They're unfortunately going to kill the person that they're in. If we give them the substance that we use for our nanoparticles as a drink, just a teaspoon twice a day, after a week, this is what the cells look like. With this completely harmless food product, we can kill liver cancer at about the same rate as the most toxic of the chemotherapy drugs. And we all know what the chemotherapy drugs do, so given a choice between chemotherapy versus this harmless nanomolecule, I know which one I would take. Now, in the next section, we'll talk about exactly how we kill the cancer and the differences and what it does to the body in general.